to our first speaker, which is Dr. Untitled. He is the president of the International Astronautical Federation. He has a really amazing resume. I just picked a few things. He's also the president of the French Space Agency, CNES. He's co-chair of the Council of the European Space Agency, member of the International Academy of Astronautics. He has many recognitions, and he holds the rank of officer in both the Legion of Honor and the National Order of Merit in France. Please give a round of applause for Dr. Untitled.
So thank you, Victoria, and congratulations for this organization, because I do not know if you decide to have this meeting here in the Victoria Hotel because it's the same first name as you, or if your parents a few years ago knew that we will have this session in the Victoria Hotel and decided to give you this name, but in a nutshell, it's perfect. You are Victoria and we are at the Victoria Hotel. So it's a very big pleasure for me in welcoming all of you to this inaugural SGAC IAF seminar on space applications, and in particular here in Montevideo. As you probably know, SGAC has been a member of the IAF for 14 years now. And last March, during our spring meeting in Paris that we organize every year, we signed a very promising agreement to collaborate even more. So what you are experiencing here is the first of what we hope to be a long series of collaborations between our very successful organizations. And I must say that I am extremely happy this is happening here in Uruguay, as I wish to see more students and young professionals from South America connected to all the space people the IAF represents. You probably know that for my agenda during my tenure as president of the IAF, I decided to promote the 3G ID, and 3G means generation, gender and geography, and it's very refreshing to be here in Uruguay. I think that this is a place where IAF has never been before, and it's very, very important to continue to have such events worldwide. This seminar today is an example of our work. You are encouraged here to discuss about the space applications from the legal, technical and collaborative points of view. I think that the space application is probably the new frontier of space, because for space today we have, of course, innovation, which is very, very important, but more than innovation, the use of satellites, what we can do with their data is very important, and this is why that speaking about applications is perfect. We will have well-known experts, researchers, managers. We will come to present their views and discuss the opportunities and challenges on this subject. So this is what I wanted to say as an introduction. We are going to have a full half day of very interesting meeting and networking. And so I hope that you will have engaging and enriching session ahead. And once again, thank you for coming here, and thank you for keeping the discussion open among the scientists all over the world. Thank you.
Thank you very much, Dr. Leal. And now we move on to our next, the first speaker, who is Günther Schreier. He's Deputy Director of the German Remote Sensing Data Center as part of the Earth Observation Center of the German Aerospace Center, a lot of centers, DLR. He has served in several functions since 1985, among others as head of the Technology Transfer Department and team leader for establishing the SAR geocoding functionalities of the European Space Agency, ERS 1 and 2, is that correct? He's also chairman of the IAF Earth Observation Committee and chairman of the International Policy Advisory Group of ISPRS.
Dear audience, dear young entrepreneurs, dear space generation, some young people are here in the room, so yes, I can say this. Yes, the youngest. I'm as mentioned by Victoria, I'm over 30 years now in space, involved in parts of engineering, design, ground-driven processing, applications, and in recent years more and more direct into management issues. And I can tell you in all these years the rate of change in technology, environmental policy change is very dramatic over the last years, and it has very much impacted space. And I'm going to tell you how much this has impacted. Where is the... yeah, this... I'm sorry about this, because this doesn't work here. Ah, yeah, sorry. Okay. So, I'm going to tell you how much this new change, some changes have really impacted specifically Earth observation, and what these new change, what is normally abbreviated as new space, means for Earth observation. And I have charted this in three different ways. First of all, looking at the demand. Who needs Earth observation? Who needs data from space? Who needs geoinformation at all? I will tell you a little bit what's the new supply of Earth observation, what the challenges, the new opportunities in supply, and lately what are the enablers which all make this happen. So let's start with the demand. Who needs Earth observation data? The simple answer is we all need Earth observation data. We all, the global citizens. That was always the case from the very beginning when we launched Earth observation satellites in the early 70s in space. It's good for all. But only since a couple of years the United Nations put a framework of the global citizens' needs, which is called the Sustainable Development Goals, on short the SDGs. So since only 2 or 3 years, or 5 years, I don't know when this was created, we have now an icon saying, look, this is good because we fulfill the Sustainable Development Goals, and some of these Sustainable Development Goals, highlighted here a little bit in more larger capitals. Earth observation is a necessary, an essential tool to monitor and to manage these goals, may it be resources, may it be climate action. It's very big capital letters here. So Earth observation is really necessary, and in our goals you can say, look, here are the Sustainable Development Goals, and this is why we do Earth observation, because the mankind agreed by the United Nations needed. And there are programs such as the Copernicus programs of the European Commission. As a European, let me allow to highlight this, which take these goals and frame this into 6 currently Copernicus services, core services: land, atmosphere, emergency, climate, marine, and civil security. Going to be widened, includes even more, but at the very end it dates back to some kind of Sustainable Development Goals, and it's about climate, it's about global action. So we need to monitor climate, and we have Earth observation data now, and time series dating back over 30 years, to monitor what the climate has an impact on the environment, or how our behavior as a mankind impacts the environment and lately the climate. So Earth observation is a tool, but also it's not, as Copernicus says, not only for environment, it's also about security. And I'm not talking about here the spies and spook stuff with security satellite and classified satellite. This has always been the case and still even be increasing. I'm talking here about civil security, so police action, and being aware of policing environmental effects like as illegal oil discharge of ships around European and other coasts. This is part of Copernicus. So you can use, in this case, radar data to monitor ships, to look at illegal oil discharge, to look at illegal fisheries on your coastal areas. This is also part of why you need Earth observation data. And you need this data fast. We're talking here of near real-time data, so it's only good as the marine or the police authorities get this data up 15 minutes after it has been taken by the satellite, so fast reaction. We also need Earth observation data to preserve our cultural heritage, the cultural heritage of our mankind. It's iconed by the World Cultural Heritage Site of UNESCO, so you can use Earth observation data, and Earth observation data is currently being used to monitor culture and World Heritage Site, to look what war and conflict has done to this, and to monitor this back and eventually take action. This, by the way, is also a potential new area of Copernicus application in the security domain, monitoring of cultural heritage. The industry needs Earth observation data. More and more industry is coming. Earth observation data was already there, but more now big industries, amongst them like agro giants like Bayer. Bayer is not a giant, but Bayer is a Bavarian agro factory. And I think it has also here assets and subsidiaries in South America. They use Earth observation data not just for precision farming, but also for assessing the global yield and the trade of food and goods over the world. And they recently also acquired a small company to get intelligence for Earth observation data. And to get intelligence, there are more and more companies now coming up and saying, look, we have all this data. I like to extract from this data business intelligence. Space Now out of California is one of these companies, and saying you want to count containers, you want to count where are your goods. We help you with artificial intelligence, with online tools doing this. And there's other companies such as the German SAP. I don't even know what SAP stands for. It's a business software company at the end of the day. And they say, look, we support your big business with our background accounting software. And why not including in most of your business assets the intelligence about where things are, what geometric and geographic conditions are there. So they have started an initiative to include in their framework software also intelligence and Earth observation data, particularly also from the Copernicus program. So this is directly going to board level, decisions derived out of Earth observation. Big players are very much interested and need data, they need continuous data. So the need, where do they get all this Earth observation data? Do we have enough? Do we have the right Earth observation satellites? Now, obviously there are thousands of objects in space, most of them satellites, many more debris, but this is just, I think, only a picture of the active satellites. About thousands or so are some kind of Earth observation satellites, but most of them are just one-hit wonders, like a scientific mission of 2 or 3 years. Have no continuity. It's good and valuable data, but it's not the kind of data the SAPs, the Bayers, the industry and the global change research can rely on the long term on. We need constant programs, we need long-term time series, and we need to have an assurance that the data I'm measuring now, they can get the same measurements also in 3 or 4 or 5 or even 20 years to come, or even better measurements, but I need to have continuity. Now, amongst others, it's, or let's state it this way, the longest continuity we have in Earth observation data with reasonable resolution is the Landsat series of satellites dating back to '72. So in some of the other slides, also tomorrow, I will come back to the Landsat. So this is one continuity program, and thanks to our colleagues from USGS and NASA, we will have also continuity on Landsat. And it's the Europeans who started the Copernicus program, which next to Landsat, which has also optical capabilities, has also radar, altimetry, atmospheric decomposition. It's getting even more. Copernicus is going to expand in Copernicus other capabilities, expansion and extension, and cross fingers for the next long-term budget for the European Commission. We will have Copernicus also in the 2030s, 40s and 50s to come. So it's a long-term issue, and it will guarantee a global coverage. This is a global coverage mosaic of Sentinel-2, already 1 year old, so we have more this. It will guarantee a long-term global coverage, and most of all, this is the success of both the Landsat and the Copernicus program. All the data you have seen are free and open. Don't be confused, not just for European citizens, also for Chilean researchers, administrators. All this data is free and open, so you can get this data from the internet, both the Landsat and all the Copernicus satellites. That's a big breakthrough. It's a big driver for using this data and working with the data. You can say, hey, what's then the business of the commercial guys? Is there still a business for them when there is Copernicus data free and open? And the answer is yes, because the Copernicus data is somehow limited in geometric resolution at about 10 meter, everything better. There is no free and open data, you need to go to suppliers. And in temporal resolution, so Copernicus is best like every week to get a Sentinel-2 or Sentinel-1 image. If you need higher resolution, and it's the SAP, the Bayers, the security guys need this, and you need better coverage, not once a week, but maybe once a day or several times a day, you go to the commercial guys. This is just an icon of a planet. They operate, as you know, the fleet of satellites. Currently, I think 80 or 100 in space with 3 meter resolution, you can better. And there's what you call new space, more and more of these companies coming up. This is a slide of last year, and if you just make this slide now, it's outdated next month. So the companies come and go and merger and acquisition taking place. But what definitely is going to take place, there is a vibrant community, there is a gold rush in, let's start some satellites, let's be in this business with high resolution, any kind of satellites. And you see more and more of this coming. And the estimate is really going up in the number of satellites, Earth observation satellites. So there is definitely a supply from the continuous programs such as Copernicus and entrepreneurial startup and big companies launching and operating their own satellites. But watch out, for some of the application, there's a challenge for using Earth observation. If you're just being interested in your local farm, in your local site, there's another entrepreneurial startup company with all these drones and UAVs coming up. They're also good for Earth observation, for monitoring. So they live currently in coexistence, and you will see in time how much this kind of stuff and new technology and other internet-based technology might challenge parts of Earth observation from space. It's a challenge, it's an interesting thing, you need to be there. We have supply, we need Earth observation data. We have supply, we have enough satellites or maybe drones in future. So who are the enablers? Now, first of all, it's all about money. Fortunately, there is, you can say, enough money. If you just look at the ESA budget, the better part, thanks also to Copernicus, goes to Earth observation. It's nice money, it's good money, but maybe, especially for wealthy countries, you can even invest more money in these kinds of assets and Earth observation from the government point of view. From the private point of view, VC companies, venture capitalists are crazy currently. I think they invest more in Earth observation than have ever. There's a real boom in getting money. If you now create a company and have a reasonable business plan and go to a venture capitalist and say, I like to start my own satellite, there's a good chance you get money. This wasn't the case 20 years ago. It's like, you're crazy, starting a satellite, go away. So there is money available, and you read the lines and see money is there for getting a space app. If you would have bought Apple shares rather than the Apple II computer, the very first Apple II computer, for the same money you have invested in the computer, you would be now a millionaire. So this is their figure. And it's about the internet. Earth observation is about digital data. At the end, it's about a piece of digital information, lots of this. And there's a coexistence of both sources from the internet and using Earth observation on the internet. Coexistence is that some of the information we're supposed to have only from space can be derived also by crowdsourcing or other means of using the internet. This is just an example of colleagues of mine that did. There is a global urban footprint. It's a radar map of urbanization derived from the German Tandem-X mission compared to Twitter accounts. So you see they both coexist. In fact, you can use Twitter also as a kind of monitoring tool, but they have to use it in synergy. Both works with the other. So internet, artificial intelligence, knowledge-based, Earth observation is indispensable. They work together, they have to work together in the future. And because it's also that Earth observation is very, very big data. Copernicus alone generates, I think it's some of my ESA colleagues, I think it was even Joseph Aschbacher said, it's the third source after YouTube and Facebook in terms of pumping data free and open to the internet. Lots of petabytes per year. And it's the big IT companies who realize this is a unique chance. So they put most of this data online and offer capability, Google amongst them. And if you are an academic researcher and have no commercial interest, Google even might be happy to grant you free access to their computing power, not only to the data, and to the computing power. And the other, Amazon, so this is what somebody from I think University of Maryland did. The other is Amazon. Amazon is not only going for the free and open data, but also for the commercial data. So it's all the data of Digital Globe, 150 petabyte now, this is a slide outdated, is online. Now this is of course not paid just by Amazon or Digital Globe, this is also some big customers behind who have interest to have all this very high resolution data online on the cloud. It's also nations who said, in Europe said, we should also have this capability to have all our data online, and there was an initiative started by the European Commission and ESA saying, look, We enable you to start your national portal. It was France with PEPS, it was the Greek and others who have also ventured to put data on Copernicus online. This is the German Code.de version. It's globally. You can look for Uruguay. You will find the most recent data from over Uruguay also on this portal. But at the end of the day, they said it's not good to really compete Google and Amazon or to be at level with Google and Amazon. So let's have a European, trans-European initiative. This is what is called now the Data and Information Access System, DIAS. There is one of the 4 consortia plus EUMETSAT. You can argue whether this was a good choice to have 4 competing consortia plus one. You will see what it comes out in future, but any of this data is online. And again, Earth observation and internet is a marriage which is ultimately necessary to develop value out of Earth observation. Final slide, if you are really interested and have some ideas, hey, I have an idea specifically as an entrepreneur to make business or a new application, there is a European-wide contest, but also internationally, as you as a Uruguayan can apply for this. You notice the URL there. The competition where ESA, also DLR, is being part in giving a challenge, and you can respond with new business ideas and to develop even better ideas than SAP, BIVER, and the other giants have with Earth observation. And having so, in response, and my final stuff is to say, we have enough Earth observation data, there is a big demand, we have now unique capabilities using the internet. It's a challenge, so go ahead and use Earth observation and have your own ideas. Thank you very much.
And we will move on to the next speaker, which is Dr. Cristina Genopapa. She's Senior Advisor in the Department for Relations with Member States in the Cabinet of the Director General of the European Space Agency. She holds an Assistant Professor position in Multiphysics at Eindhoven University of Technology. She's the chair of the Fluid Structure Interaction Committee of the American Society of Mechanical Engineers and is secretary of the Committee for Liaison with International Organizations and Developing Nations of the International Astronautical Federation. Please give a round of applause for Dr. Cristina Genopapa.
Thank you very much for the kind introduction. It's a pleasure to be here in Uruguay to talk a little bit about Space 4.0 and space applications. But where are we? Here in Montevideo. Satellites give us the possibility to see exactly where we are, and we are here. But why are we talking about space altogether? And this is a picture of that comes from a tweet of our astronaut Samantha Cristoforetti, where she's actually saying good morning here and looking at the beach from above. But okay, why are we talking about space? Why are we talking about space technologies and applications? If we were not engaged in space activities, none of us, well, especially those that came from abroad, would not be able to be here because we would not be able to guide planes. We would not be able to get weather forecasts. We would not be able to get a bank transaction to get the money here. So one day without space would mean complete, utter destruction. So space is everywhere. It's part of our everyday life in the different areas of activities. So it is important to see it as an enabler, and the previous colleague also talked about enablers, and space is an enabler in not only in expanding the frontiers of knowledge and looking into scientific and technological advancement, but also it's very important in assisting decision and policymakers in developing, implementing and monitoring different types of policies, fisheries, agriculture, rural development, border control, different types of activities, and we already saw from the previous colleague some of these activities. Space is also very important for socioeconomic growth and entrepreneurship. Everyone can nowadays access different types of technologies and applications in space. But also space, for the younger generations in particular, is inspiring and motivating. And the previous colleague talked about space as an enabler in terms of economic terms. Yes, this is a question that very, very often we're asked. Politicians in particular, when they want to invest in space, they say, So what is the return of investment? Well, 1 year invested in space gives 6 euros in return. And when it comes to applications, people say that it is at the order of 1 to 20. But now when we talk about Space 4.0 in our agency, it's in the last ministerial talk about Space 4.0, United States and Europe, we need to look at it in the difference with the different areas of space activities. So what is Space 1? Space 1 was the old times apart discussing about astronomy. Space 2.0 was about competition. The two big space powers, the United States and Russia, having a race in space. And in the era of Space 3.0, we actually call it the era of cooperation, where we actually see the two superpowers, the United States and Russia, working side by side in big missions and also in the International Space Station. So what is Space 4.0? We also have the Industry 4.0. We have, and we heard about interconnectivity, about Internet of Things, about different ways of doing things, crowdsourcing, so participation from the society. So Space 4.0 is about participation and looking at different ways of doing things, different ways of financing, and different ways of engaging with each other, with businesses and the public sector. So our role as an agency is also changing. We need to be more the facilitator. So ESA. ESA is the European Space Agency. ESA today is a comprehensive space agency engaging in all areas of space activities. And we have 50 years of experience in space, building European capabilities step by step over the past 50 years in Europe. We have also 22 member states. Well, we talked about Earth observation before. ESA has a comprehensive Earth observation system where we are developing for the European Union together with our member states, Copernicus, the EU Earth observation system. But we also have our science missions looking into Earth. And also we are looking into the next generation of meteorological satellites, which we develop for EUMETSAT. So Earth observation. With our Sentinels, we have the possibility also to monitor different type of disasters or different type of environmental activities. And here you can see the volcano activity in Bali. And recently we have also been looking at the activity of, in Hawaii, the eruption there. Navigation. A lot of things cannot happen without navigation. Europe has its own system and we're very proud of it, Galileo. And Galileo today also has, it's very, very good in terms of its ratio and gives the possibility to combine different type of data in lots of space applications. For example, for agriculture. In the area of agriculture, we can look at precision farming. We can also provide information about the soil and the salinity of the soil, the different types of moisture. So farmers can modernize the way they do agriculture to be more efficient. And in many areas, agriculture is a very big sector that provides a lot of like national gross product for the society. Science. Of course, science is something very important, and we had our Rosetta mission. And one might not immediately think, but technologies that are developed for scientific missions can be used for applications in the terrestrial area. Like the cameras that were developed for our mission there can be used for forest fires. Looking into the future, we also are going to go for ExoMars, and we have the plan to go there robotically and look into opening holes and looking into the soil there and what activities are there. So this is a little bit in terms of the missions. Now, the ISS is the largest laboratory around the Earth orbiting, which gives the possibility to look at different type of areas, to do experiments for research, but also for advancement in understanding different activities here. And we are engaging in commercializing parts of the ISS station. So we have a program called Ice Cubes, where specific experiments can be put there. in order to give the possibility to companies, universities to test and advance different technologies and do research. So when we talk about innovation, we need to be looking at the entire chain of innovation, looking from basic research to the application in the market. And the more the technology becomes mature and the applications become mature, then we move from the public sector to the real commercial activities that are taking place. And space has given the possibility in the past, with lots of different technology developments, to advance technologies also here on Earth. One of them is in the area of energy. When we talk about renewables, is the solar panels. Space, because it requests, it's very, very demanding technologically, where you need light materials. We have the possibility to develop, and we have been developing lightweight alloys, which are now used in the automotive sector. But also other areas in terms of giving early warnings, and also one of the activities where you have is also in the medical sector, with understanding also about diseases and different technology developments in that area. So space gives the possibility to empower different businesses in a greater way, depending on how we want to think about it. And of course, none of this can happen if we don't have our European independence for launching our satellites, and this is something which we have had in the past, and we will continue, and we look into the future for new and modern transportation systems. So space. Space is only one component. It is, but combined with different type of activities, whether it comes from air, drones, whether it comes from ground with different type of sensors, combining the different data and producing big data, it can be transformed to information. And there we have a lot of added value coming from the institutions, and then going to the commercialization, which is a huge market. And our role is also to enable this possibility for the future. So if we talk about space and we look at satellite for navigation, communication, Earth observation, with lots of other different activities, we made recently a strategic partnership with Rolls-Royce in the area of transportation, where Rolls-Royce is thinking of transforming the way shipping is done today, with looking into autonomy, combining the different things. So theoretically, you would be able to sit in a control room and you would have an automated ship which will be able to dock on the ports, get the cargo and move around, and then depending on how the weather is, to navigate the seas. So this is about looking into the future. Renewable energy. Energy is something that is essential for everyone. An example that I put here is about hydropower. Understanding how much snow there is, you understand how much water is going to be. So you understand how the hydropower that can give possibility for energy. You can also look about heat dissipation from buildings from space in terms of designing clean and smart cities. So space can respond to different types of global challenges, and that means climate change. That means also looking into conflicts and catastrophes. It looks about regional development and so on. But it also, in this possibility, looking at the global challenges, the European Space Agency has been engaging into the different global agendas. And that means we heard about the Sustainable Development Goals. We're also engaging in that in order to support the decision makers. Another global agenda is the climate action and the disaster risk mitigation, where we are part of the International Charter for Major Disasters in order to support the different societies. But also space is about inspiring and motivating the next generation. And we are here today in the Space Generation Advisory Council. You will be the future that will decide what space will be, the way space will enable the future technologies and applications, the way we will engage into the market. So it's about how the future can be imagined. Inside the European Space Agency, we have Young ESA, which is an informal network of young people with new ideas that they try and exchange, and we have engaged into a memorandum of understanding with SGAC in order to bring everyone together. That was back in 2013. And now our cooperation has been expanding to different areas. A couple of months ago, we had the Space Generation Workshop hosted in the European Space Agency, and we have jointly developed the Young ESA SGAC Diversity Scholarship, and the president of the IAF was also present there in the award ceremony last year. The year before was somebody that was from Greece living in France, and last year there was somebody that was from Nigeria living in the United Kingdom, where we are bringing together and embracing diversity. So space and how space will be tomorrow as Space 4.0 in our lives, it's there to be seen with the Internet of Things and the different activities. And I would like to leave you with a small video of how a day would look like in Space 4.0. How space should be tomorrow, and all the tools are there with space as an enabler to do anything we can possibly imagine. Thank you very much for your attention.
And now I would like to introduce Dr. John Horik. He is the inaugural holder of the Neil Armstrong Chair in Aerospace Policy at The Ohio State University. He is Senior Advisor to the President of the IAF. Prior to joining The Ohio State University, he was Vice President of Teledyne Brown Engineering Space System Group. He also served as Vice President of the University of Alabama Huntsville. He also had an impressive career at NASA Marshall Space Flight Center, having achieved the level of Senior Executive Service. He is also a Federal Aviation Administration licensed private pilot with instrument and commercial pilot ratings and an FAA flight instructor. Please give a round of applause for Dr. John Horik.
Good morning, and thank you for the chance to be here. It's an honor to follow my colleagues, Dr. Günther Schreier and also Christine Giannopapa, to talk a little bit about space applications. So I hope that I can leave, by the time I'm done, I hope that for the young space professionals and the young students in the audience, maybe I can give you also a little bit of inspiration about the promise and the future of space applications. So first, just 3 small facts to share with you. The first one related to global population. There are more people living inside that circle than live outside of that circle. I thought that was an interesting fact, which I came across on the internet, of course, where you learn everything. So we have a really interesting distribution of human beings across the planet, and it's clearly not uniform. But people aren't the only things living on the planet. We also have other plants and animals, and look at where we see the most global biodiversity. And I think it's fair to say that where we have biodiversity, we have both a very healthy environment as well as a treasure that we have to take care of, not only for the sake of the biodiversity itself, but for ourselves. And if you look at that circle, we're sitting in one of those circles right now. The Amazon Basin in Central and South America, Central and South Africa, and Southeast Asia. And then we look at economic activity, and this is some research that has been done by BBVA, the Spanish bank. And if you look at where economies are emerging, so this is not the level of economic activity, but the growth of economic activity. And the countries in blue they called eagles. Those are countries where the economic growth over the next 10 years is expected to be larger than the average of the G6. So the level is not the same, but the rate of growth is greater. And in the green, you see countries where the expectation of economic growth is expected to be maybe smaller than average, but larger than the bottom or larger than the smallest entity in the G6, being Italy. So what I find interesting is that those circles generally overlap. So I would encourage you, as you're looking through your studies, or where can you make contributions to the application of space in Space 4.0 or 5.0, where you see people, where you see biodiversity, and where you see economic growth all intersecting. These are key areas where satellite observations and satellite applications can make a huge difference to solve very important problems for people everywhere on the planet. And these are not intellectual problems about, you know, what is the spin of the nucleus in the magnesium atom, but how do we feed people? How do we give people clean water? How do we assure security and stability to create social, economic, educational, and quality of life outcomes for people everywhere? Here's one that we're working on in my home institution at the Battelle Center for Science and Technology Policy at The Ohio State University. You are all aware of the Ebola outbreak that has occurred most recently in the Democratic Republic of the Congo. And it turns out if you take a look at the destruction of forestry and biodiversity, we're learning that the destruction of biodiversity and forestry in this part of the world is a significant indicator of the potential for outbreak of zoonotic infectious disease. And so we're looking to see, my colleague Sam Malloy, who is the graduate student leading this research, how can we use Earth observation to forecast infectious disease outbreak? Now clearly a satellite can't see a virus from space, but you can see things that happen from space that may allow you to predict, hey, we need to take a look here, we need to send some people in this location because we see that this intersection and the loss of biodiversity combined with population, this biodiversity loss appears to be at the intersection of where infectious disease may emerge. So just one example. I want to leave you with the left-hand side. You don't have to be Elon Musk. You don't have to be Jeff Bezos. Space commercial entrepreneurship is not about having a lot of money and a huge fortune to create a smaller fortune through the building of rockets and launch pads and astronauts and densified propellants. All it takes to build a satellite application is the left-hand side. Free satellite data. Copernicus data is completely available to you from Sentinel. Their Landsat data is available on the internet. I think you can find that just about anywhere you go. If you have a coffee shop with an internet connection, you have the first raw material you need to become a space entrepreneur. Second thing is, of course, a computer with an internet connection. You need a brain. Everybody has a brain. There is no monopoly. Even though half the people live in that circle, that's not where all the intelligence is, that's only where half the intelligence is. Everybody has the capability to think, to learn, to do. Of course, you need to feed yourself, so pizza is an essential element in a satellite application. Perhaps you prefer hamburgers, I don't know. Here I should have put a steak, a nice beefy steak here in Uruguay. That's all it takes. You don't need to go to Silicon Valley. You don't need to be a wine and dine venture capitalist. Yes, they're throwing money at problems, but you have the ability here, anywhere, to build a successful commercial satellite application that can help people. So they're amazing tools. We have billions of eyeballs. People everywhere are watching. Everyone, everywhere, all the time. Now there are certain downsides to that if you're interested in privacy and those kinds of things. But the point is, this can be something that everyone, especially young professionals and students coming into the world, can make a huge difference. We can integrate many kinds of information. Something I see in my students that was different from when I was in school is this thirst and this desire to integrate information from across many disciplines and many domains. I wanted to be the best astrophysicist that you could ever find, and if I learned to play guitar or something else, that was fine, but it was very straightforward. We wanted to be mechanical engineers, I wanted to be electrical engineers, I wanted to be X. Now, my students, at least, perhaps your experience differs, this desire for integration. Space applications and space data, along with in situ data, give you a strong opportunity to be integrative, to connect things together. As we've noted, the data are abundant and free, I should mention that again. And the only thing you need to distinguish yourself or your ideas or your team's ideas is your intellectual capability. and everybody has that potential. There are no significant barriers to entry, as I mentioned. You don't need a big factory and a huge Tesla battery pack. You just need some innovation and an internet connection. Our tools are common. If you're trying to solve the challenges of biodiversity loss in the Panama Canal, or you're trying to solve monitoring of rain in the rainforest in Indonesia, or you're trying to understand oil spills that we talked about before, the tools are the same. And what is applicable in region A for the world is very likely applicable in region B for the world. And so we have the ability to develop one tool, one opportunity, one idea, one product, and it has applicability. Perhaps not exactly, you need to tweak it a little bit. For example, to go from soybean to corn, if you're agricultural analysis, but you can leverage intellectual know-how and progress from one part of the world to address in other parts of the world. And as Christina pointed out, I think this is worth emphasizing. The landscape is also different for innovative partnerships. You have a different world. It's not just NASA and the Soviet space program. It's not just ESA and Roscosmos. Space is now almost a utility. We don't even think about it. If we turn on the tap, and the water comes out. We turn on the light switch and the electricity is there. Space is very similar in that regard, and because it's that way, we now have many, many different ways to partner, to integrate ourselves, not just intellectually, but organizationally, among government, among non-government organizations. I know that the Secure World Foundation is here to join us this week, and the private sector. So this collaborative environment, it's as if we had built a new molecule, which at one point in time perhaps was more like helium or argon. All the shells were filled and it was useful, but you know, you can inhale it and make your voice sound funny, but it wasn't really good for chemistry. The world today is much better for chemistry. We've slided to the left on the periodic table. We haben nach links verkehrt on the periodic table. I don't know what the word is, but carbon is a strategic molecule. It binds 4 different times. You can put 2 double bonds on a single bond. The world is like that now. And it's also very transparent. It's hard to hide. The world can see what you are doing. And this is important for security, yes, for national security, but also for the kinds of security that Gunther and Christina have talked about. So these raw materials are all available. They are all abundant. And it is not the more experienced people here who will help figure this out. It is the young generations, the young professionals, and the students. And we welcome your engagement in the space community, even if you are not a traditional space community participant. Space is open. Space 4.0 and 5.0 is open for everyone. So with that, I'll conclude, and I'd be happy to take any questions. Thank you very much.
To introduce the last speaker for this section, that is Dr. Pascal Ehrenfreund. She is chair of the executive board of the German Aerospace Center, DLR. Between 2001 and 2005, she held a professorship in astrobiology at the University of Amsterdam and the University of Leiden. Then she was distinguished visiting scientist at the Jet Propulsion Laboratory in the USA. She has been professor of space policy and international affairs at the Elliott School of International Affairs, George Washington University, and lead investigator of the NASA Astrobiology Institute. She was also the president of the Austrian Science Fund and a great role model for all women in aerospace. Please welcome Pascal Ehrenfreund.
Thank you very much for inviting me here. It's quite some time, but I have been here before, and I was actually pregnant with my son, and I didn't even know yet when I was in Uruguay and was traveling through South America. I've been a lot in South America because I'm an astronomer, and I've worked in Chile and also for Mars simulations in many, many regions here. So it's always wonderful to come back. There's so much which has been said already by my predecessors here this morning, and I just want to add a few more points, probably which have not been discussed so much in detail. I actually changed my presentation in the last 5 minutes, you know, and thrown out half of the slides and put some others. I just want to introduce you very briefly the German Aerospace Center, which is the largest center for space and aeronautics in Europe, research center. And it's also at the same time the space agency, the German Space Agency. And I think what's important for space application is that we are not only working in space and aeronautics, but also in the energy sector, in the transport sector, in the security sector. We have a new cross-cutting area of digitalization. And you have heard many examples this morning already, how important space application seems for our everyday life. And that helps us also in DLR to have all these different research areas in-house in order to actually also understand and design applications for space. So this is a little bit an area which we have discussed already today, Earth observation and communication. And we are actually working on all the different sectors, also, of course also on space transportations and space exploration, which are also really important topics. But just that you see a little bit on the cake, Earth observation take actually quite a large part, and we have heard so much about it in the previous discussions today. So it's always important to see how the market is reshaped by these new space initiatives. But I think something what we haven't discussed in detail today is that new space works very well in the United States. And actually in all the other regions in the world, we have to work very hard, you know, to have this kind of entrepreneurial spirit and this kind of investment and venture capital. And we have actually to find different answers for this new space area, which works very well and has really boomed in the United States with the constellations of satellites, advancements in reusability, in particular in the launch sector, on-orbit servicing of satellites, discussions about space tourism. And of course, we see also more and more countries, you know, being interested in space, and that applies, of course, also to South America, but also around the world. We have just been a few months with the IAF in Africa, where there were also many countries interested in space application. Is one of their main goals, of course, for the future. So we have this kind of very strong influence of, as you say, space 3.0 and space 4.0, but it's not in every area of the world that it goes as fast. And in Germany, we made a study about new space and what is actually missing, what kind of recommendations can be done in order to understand where space applications are important and to find market drivers. And we have talked a lot about geoinformation services today. We have also talked about big data and global data networks. We've talked a bit less about autonomous systems, which is also something which is really important. But I think every country has its own national programs as well, and you have to understand, you know, where are your market drivers and where can you work nationally on the European level or actually globally. I think this is how the market of space application will also continue to develop. And our space administration is currently looking at space 2040 and what will be important for the future, and what role will space application have. And then you look at the areas, and some of them have been a little bit discussed today, but space and mobility is of course something which is a very important sector. Also global connectivity, cybersecurity, a topic which is more and more becoming emphasized, and of course Space Industry 4.0 we have discussed already. So it is not obvious that space is a really, I would say, a prime player in that. It has actually to fight for its role, because when you have global connectivity, you have a lot of ideas, terrestrial ideas, so satellite technology, you know, and 5G. It is not so such an enormous connection. You have really to make people and in all the digital agendas of countries, you have to make a move and say how important space is gonna be. And it is not obvious that space is automatically seen as a major player in all those areas. And I think it's up to us and it's up to the new generation to find business models and to actually push space into this digital agenda of the future worldwide. And obviously there are many different applications, be it tracking and tracing, geofencing. Some of those things have been discussed already. And of course this ultra-precise satellite navigation is for the networks of transportation, and mobility is intermodal mobility really crucial. There are so many ideas which in particular young entrepreneurs and smaller companies and students could have in order to contribute. And be it communication and space sensors and robotic autonomy. So this is something which we really have to foster in the future, that those ideas are coming. Otherwise, you know, terrestrial solutions will probably be dominant in some of those areas. And this has to be a very active field, and particular young people are crucial, you know, for developing that. Now coming back to Earth observation, which is, I think, quite a well-developed field already concerning space applications, and you have heard from Dr. Schreier this morning already. We are very proud of our radar satellites. You see them here monitoring more or less the entire Earth surface, TerraSAR-X and Tandem-X. And I think they are, for Germany, a really great example how we actually have made collaboration with industry and business models. TerraSAR-X is serving the global community now 11 years. And there have been so many scientific data which have been interchanged and proposals with scientists, but it is actually a very good model for public-private partnership with Airbus, and those data are distributed, you know, all over the world for many different business cases. And for the scientific point of view, of course, you've seen so many nice pictures, so I show you also one nice picture which shows us actually the increase of ice flow in the Drygalski Glacier in Antarctica when after the Larsen A shield has been broken off, and actually the speed is increasing, and of course this is not going as fast as this picture. But you see what you can actually do with Earth observation to understand our planet, and I think this is a really wonderful demonstration of our radar satellites. And Tandem-X has made a global digital elevation model of the entire Earth's surface, and there are so many beautiful examples. And those data are really well thought of all over the world. People just want to have this data, they buy those data in order to use them for many different purposes. And you have heard already about the global urban footprint. So one of the future missions, which we are also engaging with many different partners, nationally, European and internationally, is the Environmental Mapping and Analysis Program, ENMAP, which is a hyperspectral application looking at what we just discussed now, John Horik, biodiversity, something really important, and forests, and looking at our planet. And also with the Copernicus program, of course, you see that a lot of national satellites are trying to fill some of the gaps. and trying to contribute to this really important little gaps, you know, which are not taken, going into higher resolution, having more channels, and looking at faster pace at our Earth, or looking at very specific businesses, or of course in the Earth observation, be it coastal, be it a landscape, and the examples which we have heard already today. So I just wanted to announce one very nice cooperation between Teledyne Brown and also the German Aerospace Center. We have just actually sent the instrument DAISYs to NASA, which will be launched to the International Space Station in hopefully in August or a little bit earlier. And this is the first Earth observation instrument, which is in the optical between 400 and 1000 nanometer. It's going to look back to Earth, and with also a hyperspectral instrument with 235 channels. And there is a platform which is on the ISS, the MOSES platform, which was built and designed by Teledyne Brown, and this is actually a host platform for many different instruments, many more to come, hopefully at least a space for 4, and of course you can also interchange them in the future when you have new ideas. And I think it is a really great idea and importance that we have also Earth observations, you know, which we can perform from the International Space Station. And at the end, I wanted to come to one point which was haven't been discussed today. We always really are very impressed, you know, by space entrepreneurs, by many different companies which have great ideas. We also know that not all of these ideas will actually be realized. But we should not forget that also the state somehow is really an entrepreneur. And in Europe, there is since a few years a really famous book. It's called The Entrepreneurial State. And it is written by Mariana Mazzucato, which is a really important advisor to the European Commission. And she has analyzed, you know, many examples, and particularly also internet, iPhone, where do the components, you know, for all these kind of new ventures and ideas come from. And they are actually coming mostly from state-funded, a lot in the United States, from DoD, from DARPA, from many, also from the defense side. So there is a lot of money which comes from the state, you know, into these first, you know, innovative developments, which then are further, I think, developed by space entrepreneurs or companies. So you should not, also SpaceX has been heavily funded by NASA, everybody knows that and is still. And so we should not only think, you know, that the answer in everything what is innovative in space applications, you know, is gonna come from smaller companies and so on. I think there is this really important basis of the state being also an entrepreneur and investing enormously in basic research, in blue sky research, in order to make all this happen. But what is really important for the future is this kind of brains of the young people and the great new ideas and connecting and working more interdisciplinary and synergetic than my generation. I did a PhD in 2 subjects, combining it. That was a big crisis, you know, at that time. And I think today I see a lot of young people having many different masters in geography and then in space research, and combining that. And I think this is where the answer lies, and also, you know, exchanging with the other people working from different fields. That will be very, very crucial. As you have seen today, where does space play a role? You have heard that in all these talks this morning, in the mobility sector, in the security sector, in the industry 4.0, Earth observation, so many different subjects, and you need this kind of synergistic and interdisciplinary approach in order to really have good ideas for the future. And this is, we all hope that you will also achieve in your working groups today and in all the other conferences. Thank you very much. Chocolate, very important.
Very interesting. I like what you said about entrepreneurship and the multidisciplinary teams. That is also very important for every successful venture. We have time for one question. Anyone? Yes, please.
Hi, thank you for coming. I work at the university here in Montevideo. And you were talking about city mobility. And I would like to know how that intersects with the industry, the 4.0 industry and smart cities. If you have applications using satellite technology and the use of IoT sensors. I don't know if...
I didn't get the last sentence, but so for instance, we have also in Germany, we have an initiative which is called Space Moves. And it's a bit strange in the, actually it's better in German, yeah, Raumfahrt bewegt. But what it does, it brings the different players from the different areas, research areas and also businesses, of course, together. So that you actually understand each other's business. This is something which is, sorry, this chocolate is really good. And so it is very often very important to bring people from different areas together, and we have a very strong automobile industry in Germany, obviously, so this was a very logical conclusion. And you have to understand, you know, how transportation works in the future, how it is connected, you know, how intermodal mobility works, and what you can do with satellite applications for that. This is something which people can only learn when they are working together. But we know also that the mobility sector is very strongly tied to you know, smart cities, and also to the energy sector. Energy and transport are coupled. And it is so there are some examples, obviously already, where people are discussing, but it is a field where only through to the interdisciplinary discussion, you know, and bringing the people together in the first place, you can build up new business model. And so what I can just tell you from the German side is we are trying to initiate this dialogue and to find opportunities. For us it's also good because we at the same time we have also aviation, which is of course also a part of the transport sector, and bringing that all together I think is a really important thing. In every country, you know, you should try to bring those actors on one table in order to define what is important for your country and for your cities, and for reducing emissions and having a better transportation, and how, you know, satellites can help with that. So that is, I think it is something which is only at the beginning, because you have to bring the communities together.
Perfect. Thank you very much, Pascale. SGAC and IAF are think that it's very important to take the ideas and the visions of the younger generation, I mean the students and the young professionals, to the decision makers. And that's why we, in the events that we do working groups and we discuss the different ideas, and all that is then presented at the United Nations to all the world aerospace leaders. So in order to start, we have moderators for each working group. First, for the group 1, that is Internet of Things and Space Applications, that's going to be me. For the group 2, Legal and Policy Challenges of Space Applications, it's Crystal Wilson. Crystal? Where are you? Oh, there is Crystal. So for group 2, you have to look for Crystal. Group 3, Technology Development and Space Applications, that is Beatrice Barresi. I'm sorry, I forgot to introduce Crystal. Crystal is Director of Space Applications Programs of the Secure World Foundation from the United States. Beatrice is in Group 3 and she's Applications Engineer for the European Space Agency. Beatrice. So for Group 3, you have to look for Beatrice, she's the moderator. And for Group 4, the Regional Collaboration in Space Applications, we have Nicolas Peter, that is Head of International Relations at the German Aerospace Center, DLR. Nicolas? Okay, so for Group 4, you have to look for him. So in order to divide, I mean, I see we did some tables, but I think it's going to be small for the tables. So please look for Florencia in the back. There she is, she has a list. So to say to which group each one should go. So yeah, you can start looking for Florencia. Thank you.
Not only for such programs like grants projects, which are obviously driven by public money and states, but even private companies release a number of their data sets for to use, knowing the benefits and spin-offs and applications that can come up as a result of the use of these data. So I think particularly on the policy level, this development of open data is very significant, and I think for those who enter the world of space applications, or also let's say from the perspective of an agency, it's important to know that there is already backup support for this trend, and you're not alone saying that you want more, because a lot of organizations already have achieved progress in this field by liberating data and making, in fact, convincing space agencies, space private companies to share more, and this is, for example, the case.
I will expose and talk about what we did. We attacked the problem of city mobility accessibility, as it is a major social exclusion here in Uruguay. And we attacked the problem with a pragmatic approach. The problem falls in lack of infrastructure and lack of ramps in the city. And that happens in a lot of developing countries, as Uruguay. And the idea is to use geospatial information that exploit the spatial and transport data generated every day to attack the problem and give information to the users to travel in the city. For example, with the use of an assistant bot. You can see the images on the slide in a map, in a travel route, and the application can inform the user different alternatives to travel in the city. Information about where are the ramps, the state of the ramps, and it will for sure improve the city mobility, in special for the people who need it more. Thank you. I will give the word to the second speaker.
Well, we form part of the first group of IoT application space. We focus on the agriculture's problems. We detect 4 kinds of problems in the relationship with the agriculture. The plagues of the plants, of the crops, the floods and drought, the issue about agricultural techniques, and the excess of pesticides. The plaques, also, we can detect him about images from the satellite, from visual range and infrared range. The flags and drought we can detect with visual range images. And the issues about the agricultural techniques with the same images. And we can define with these images the excess of use in pesticides in this. We have sensors on grounds, we have data from another services, and we have images from the satellites. From their sensor we can measure humidity, chemical composition of the soil, and temperature. These sensors are, we collect the data with the local communication network. We can use weather forecasts, solar maps, and coordinate index and historical data to introduce to the same server. From the satellite, we use a visible range and infrared image to determine the green index. It is an index that measures the chlorophyll of the plants and can determine if you have a plague or not in the crop. You can determine the kind of plagues with this green index and what dose and type of pesticides you can use in the agriculture environment.
Of course, for that combination of sensors, data, and satellite, we need a good combination of backbone network, from the local operator of telecommunications, and agreements with satellite companies, and of course good aiding for some data center that acquire the data from the sensors and from the satellites. Okay, that's all.
Hello everyone. I'm the third within the IAF team. We started with a simple issue when we started thinking of an IoT solution to address this issue, and the issue was the issue we wanted to address is the life cycle of plastic pollution in our oceans. The main process that all plastic pollution ends up going through nowadays is we start with manufacture of any product. It is then consumed, disposed of, and eventually it becomes waste. So what we wanted to tackle was the specific part when the product is disposed of and eventually becomes waste that ends up polluting our oceans. So this is where we came in. We tried to take an approach between the disposal of the product and turning that disposal of something that has been used and was useful and fulfilled the function and turn it into an opportunity. Now this sounds as a great thing that we could implement, but how do we do that? We thought of a smart tracking system in order to be able to turn that disposed product into an opportunity for either reducing contamination to the environment or reusing the materials used in the original product for new products. So our IoT solution, we started listing several of the elements that we would need to include in it so that it would be functional and practical to implement. The first sensor that we would need to include in our solution would be a position tracking system, either by GPS or other technologies, to be able to track the path that our trash follows from disposal all the way until it becomes waste. And the way we would do that is through position tracking, so that we could eventually recover the waste and either reuse it for new product manufacturing or dispose of it correctly as it should have been done originally. The tracking system is how we would enable that. Another sensor that our IoT device would have to include is a chemical signature reader, so that we can identify what kind of waste we are encountering in the ocean and therefore find a way to deal with it properly. And finally, the other sensor that we would need to include is a temperature sensor, so that we can also correlate the position where most waste is found in the ocean to different climate change hotspots and get data of the way our trash and waste is influencing climate change in that way. Thank you.
Thank you very much, Group 1. Very interesting ideas. And now for Group 2, legal and policy challenges of space applications, that the moderator was Crystal Wilson.
Hello, my name is Isidora Casas del Valle. With my group, we basically had two questions. One of them is, what are the challenges, the legal and policy challenges that governments face, and also the recommendations to these challenges. One of the first things we had was that usually governments don't all have a defined space agenda, and that's the first thing we should do. Also, there's a lack of information resources available in a variety of languages, and just to make a point out of this, muchos de nosotros hablamos español, y el problema es que no está todo en español, and that's how we feel usually, that everything is in English, and we need other languages, especially because most things like the Moon Treaty or the Space Treaty are in English and any other languages from the UN, but many other resources are not. So we need to make them available for everyone. Also, governments struggle with bureaucracy, budgets, time. One of the discussions we had is, for example, Paraguay or Chile, we have a lot of problems with that. To be able to pass a bill or to have a space agency, it takes years until we can actually make things happen. Also, there are discrepancies between international frameworks and what's actually implemented at a national level. There's a lot of international treaties that are not enforceable, or what the nations do in their own laws, in like domestic laws, and how is that related to the international frameworks. And there's different communities need to be more available and be more aware of space applications. Many people don't know on what we use space. Usually when they say, I want to be a space lawyer, they say, why? Do we even use space? And I'm like, well, if you use your phone, that's exactly what you need to use GPS, to make a phone call. It's important to be aware of the uses. And also their interested space actors are unaware of the legal and policy considerations we need. I get a lot of questions as well of, I want to develop an app, what do I need to do? Or I want to launch a satellite, is there any legal framework? We need to get that information out there, especially in all languages as well. And for the recommendations we have is, first, increasing marketing and promotion of the uses of space applications. That's for the UN, from governments, the industry, the private and public sector have to work together. So people know what space, all the assets that space have, or why we should study. We should include space as core courseworks in universities and schools, and not just STEM. I mean, science, technology, engineering, it's very important, but from the law point of view, or cartography, as we had another of our applicants here, it's very important. The IAF also should continue to do more regional conferences. Maybe we should have an IC here in South America, just like the one in Germany, or Australia, maybe we should have as well, just like this one right now. We need more scholarships for students and young professionals to get out there. Some of the scholarships available for people to actually study or attend these conferences are only limited to countries who have a space agency, or who are part of a convention or a region. But we're leaving behind everyone who also needs it, just like us. The public outreach by space agencies and other space actors is also fundamental. I think personally ESA does a great job with that, on putting different banners and everything in airports so people can also realize that it's everywhere. And newsletter, and to encourage media outreach, there should be maybe a sector in media, or CNN could have a small space not only for Elon Musk and launches, but also for everything else that we use, imageries, satellites, among others. Thank you.
Now I introduce the third working group, which is Technology Development and Space Applications. The moderator was Beatrice Baresi, and now Federico will make the presentation.
Hi, I will be talking in behalf of Group 3 regarding the development of technology and improvement in space. We are going to target three main issues. The first one is the communication between the satellites and air equipment, and to improve the accuracy of the measures taken in the satellites. For example, satellites that take optical images or radar images of ground could use hubs and UAVs to improve that images having double. They could have many images taken with radars. They could have the UAVs and the hubs send radar signals to ground to bounce back to the satellite and take more images and have a more accurate and a highly definition image taken. To target this problem, we should build radars that are lighter, and also to have the hubs to improve the absorption of the solar energy, to develop the solar panels, as to have the hubs and the UAVs with more power and could fly longer in periods of time. We also need to communicate the satellite and the hubs and the UAVs automatically, and that is an improvement we would like to do in the software and the communication between machineries. Another issue we target is the data usage, and this is, we may have a lot of data sent, received that is not needed. We need to stay with the information we need and the relevant information, and that could be done filtering better the information, having a better software. Also, it could be reached by a communication by the software, the ground software communicating directly with the satellites and asking for the information pertinent to what they need, and not having all the information storage in a server and then sent to the user for the user to process all the information and extract only what they want. So improvement in satellites and in software inside the satellites must be done, so the communication to be possible and to contact directly with the satellites. Okay, another thing we target, third thing, and to go more over and a more extensive improvement, is to make the satellite not also receive, process and send information, but to affect the climate and the ground status. For example, preventing improving weather predictions with better images, better all of that, and better predictions and modeling, and also change the climate to prevent some disasters. For example, a signal could be sent from the satellite to change certain climate and temperatures that could prevent hurricanes from forming, and that's pretty much it.
Thank you very much, Federico. And now we move on to the last group, that is Group 4, Regional Collaboration in Space Applications, which was moderated by Nicolas Peter, and Juan will make the presentation.
Hi everybody. Well, regional collaboration, space applications. there's a great thing about this region. We just have two languages, or three. We count Guyana, it's just Portuguese and Spanish. That means the only country that doesn't speak Spanish in the region is Brazil. The rest is all Spanish, which is great to collaborate, isn't it? So in terms of challenges, we found a lot of challenges, opportunities. I would love to put it that way. I hate the word challenges. So it's a lack of broadband connectivity. I mean, it's hard to find a full coverage broadband connection capabilities in the region. There is definitely a problem with mobility infrastructure, especially in Central America and some regions here in South America. There is actually not a political umbrella that can take a leadership regional structure, which again is a challenge, but I don't know if we need space agencies, leaders here. We just need more collaborators. There are definitely environmental needs, especially in countries where are totally related with agriculture, cattle, and farming. And there's asymmetry of needs between countries in the region, totally. I mean, I love to say that, but there's a lot of differentiation between some countries in Latin America, some regions, and others. But there's a lot of opportunities, especially educating the public and breaking down the gap between space, science fiction point of seeing, and this kind of Earth technology applied, like application. So there's definitely a political stability that can help us to collaborate even more, especially in countries like where we are now in Uruguay. We are definitely taking the lead in terms of innovation, human rights, and also One Laptop Per Child program from Nicolas Ponte. This was the first country in the world that was held and tested. There is a dynamic private sector, quick implementation. We are very, very, very able to almost start any MVP or any testing program without the need of the government approval, and with the worst conditions ever in terms of money and in terms of, some type of connectivity to the global world, that can allow us to test and to try things that never done before in an easiest, fastest way, and establish Latin America as the place to test and prototype things for the world in a faster and better way than maybe in Europe or in other places. So there are multiple actors emerging for synergies, and they're looking for it. So our recommendations in this group, led by Nicolas, was actually to establish more regional events more often and consistently. Instead of trying to get into Brazil, Argentina, or these big players of the region, just start to create small hubs that they can lead events and put the space application or space exploration or space technology into the people. Not into the big companies, just into the people with small workshops of this one, and having people like you flying here, trying to inspire young people to get into this. And that would definitely reduce the gap between space, science fiction, and reality, as I said. I remember once I told to my father I was going to something in Dallas about spaceship interfaces. And he said, what it has to do with web pages? And he said, everything that, and still people asking that, and we are in 2020. So creating more regional resources management, I think that people dream a lot here. We have a lot of opportunities, a lot of talented people, but we need from you guys the opportunity to connect those dots and become a bridge. It's like when you get a degree from the university and you don't know what to do with it. This is the same thing. We have a lot of people, we have the ability to connect with the technology, but what next? We need from you, we need challenges, we need testing, we need, problems. And so people can feel that they are in Uruguay, they are in Paraguay, but they are actually global citizens, and they are solving in some way global problems. I think education, as a mindset education tool, can help a lot, and you guys are definitely, every kid dreams about space, and dreams basically, when you dream, you look up. You don't look down. So actually you are here the ones that need to inspire us and to help us to dream and to become those dreams true, especially in Latin America. And to create common policies, but not too heavy policies, simple policies that can keep us more connected and easier to collaborate. in terms of speed and testing and prototype, as I said. So thank you so much for coming, and enjoy the rest of the days in Uruguay.
Thank you very much, Juan. And now we came to the end of the first SGAC IAF seminar. I would like to thank all of you very much for coming. Also to our VIPs, Krikalev, Pascal, Mendieta Jimenez, well, all of you, Gunther, Gabriela, all of you, thank you so much for coming. I would also like to thank all the people that has been organizing the conference here. If you can come up, please. Isabela, Florencia, Juan Chapesoli, please. Can you come? Julia Maria is here. Okay, so Emma, Stephanie. Yeah, come on, you're a CAC. So this event could not have happened. I'm sorry, did I forget someone? It's like, I don't know, I don't see Julia Maria or, well, Christian, of course, thank you so much. But this event wouldn't have happened if it wasn't for all the help of all these amazing volunteers. So please give a round of applause for all of them.